Let's look at this example. We want to calculate the work done on a block of ice by a person exerting a 200 Newton force if the block is displaced by 5 meters to the right as shown. What's important here is that they've given you theta. It doesn't matter that the force is being pushed down. That's irrelevant. Whether it's being pulled or pushed, it doesn't matter. The point is the angle. So, F is 200. Theta is 5 meters. Sorry, delta x is 5 meters and theta is 25. This is a straightforward substitution, and he does 906.31 joules of work. We're not concerned how that work gets translated, but that's how much energy he's doing. If now we change the situation and he now pulls the block of ice, remember again, it doesn't matter whether he's pushing or pulling. What's important is now theta has changed to 30 degrees. That's the important part here. So if F is 200, same as delta x is still 5, theta is 30, we get a smaller amount of work done. The bigger theta becomes, the smaller the amount of work done. Okay? How much energy is transferred in both examples? Well, the energy transferred is the amount of work done. Energy in number 1 is 906.31, and in number 2, 866.03. So please remember, and I'm just going to write it in here for you, all right, that work decreases, okay, when theta increases. Okay, that's really important. Maximum work is done when theta equals 0, okay? Or 180, it's just going to be work that's negative, okay? Minimum work, all right, is when theta equals 90 degrees. And we want to try work with the theta that's either going to be between 0 and 90 or at 180. We don't want to work with anything in between that, okay? So, a 100-gram apple is thrown, so the apple is moving up and reaches a height of 4 meters. Gravity always acts down. There's absolutely no exception to that. They want the work done by the gravitational force on the apple. Well, theta is delta x is 4. Theta is 180 because the apple is going up, but going up, but gravity acts down. Gravity is going to be F equals mg. It's how we work out gravity. So the force the apple is experiencing is 0.98 newtons. Straightforward substitution. We get a negative value because as the apple is moving up, my apple is losing kinetic energy. It's getting slower and slower and slower. So negative work is happening. Work is being transferred to the surroundings. When we calculate net work done, the net work is the sum of all the work done by the individual forces on the object. There are 2 ways we can do this. My preference is the second, but it really is up to you. Best way to do this is an example. So a truck of mass 2,000 kilograms, free wheels, which means brakes aren't being applied, the foot isn't on the accelerator, they're allowing it to just move under the force of gravity, down a long 30-meter long incline. So what they are saying to us is that the distance, delta x, that the truck is going to move is going to be 30 meters. The plane is inclined at 30 degrees. The truck experiences a frictional force, of 5,500. So that's in that direction. Please don't forget, and this is one that's going to happen often, there's still gravity, okay? Gravity is still acting on the object, and in fact, it's going to be FG parallel. That's the important one here, because only part of gravity is acting on the object, because that's the part that pulls it down the slope. So what I actually kept forgetting to put in here is the question is this, okay? Calculate the network done on the truck. That's the calculation, okay? We're going to do it two ways. So the first thing, please, a free body diagram is incredibly useful because a free body diagram allows us to know how the forces are acting. So there's the free body diagram. Of course, I have left out a force, which is over here, which is Fn, but I left it out because it acts at 90 degrees to the motion. It's not going to do any work. Okay, so first method, we're going to calculate the work done by each of the forces. So the first one is work done by friction. Friction is always cos 180, and it's minus 165,000 joules. Okay, that one's easy. Now we need to do the work done by gravity. When we look at gravity, now we've got to go, why am I using cos 60? First of all, that there is for the calculation of gravity. That's mg, okay? The 60 comes from this. So my force is acting down. My object is acting in that direction. That angle there, because that is 90, that gives me 60. It's one of the reasons why I personally do not like this method, because you often get that 60 degrees wrong. Okay? That gives us 294,000 joules of energy. Now we can go, well, W net is WG plus WF, work done by gravity, work done by friction. We never change the negative work to a positive. It stays as a negative. So the total work done on my object is 129,000 joules of energy. That will translate into a change in kinetic energy for my truck. That's the first way. The second method is this. F net equals Fg parallel plus Ff. I'm working out the net force parallel on the slope. Fg parallel, remember, is Fg sine theta minus force of friction. That's from grade 11. 2,000, that's the mass of the truck, times 9,8 sine 30, okay, minus 5,550, 4,300 newtons, okay? That's the net force. It's a positive net force, which means net force is in the direction of the motion. Theta is then going to be 0. 4,300 times 30, that's 30 is the distance. Oh, look, 129,000 joules. Same thing. You will eventually find a method that makes sense for you, but sometimes they will specify. Which means now you need to go through activity 1 on page 161. The memos are on Teams.